Hello and thank you for watching my video. My name is Astrid Krasniji. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA Semester 2 Routing and Switching Essentials, and this is Chapter 2. This is Section 2.2 Switch Security. In here we talk about management and implementation. We should be able to describe basic security attacks in a switched environment, and be able to describe the security best practices in a switched environment. And then we should be able to configure the port security features to restrict network access. SSH operation. Secure Shell SSH is a protocol that provides a secure, encrypted command line based connection to a remote device. SSH is commonly used in Unix based system. The Cisco iOS software also supports SSH. A version of the iOS software including cryptographic encrypted features and capabilities, it is required to enable SSH on Catalyst 2960 switches. So you have to make sure that you have iOS that does support cryptography, or you're not going to be able to enable that SSH. Because of strong encryption features, SSH should replace Telnet for management connection. You should always, in production network, use SSH instead of Telnet. Now Telnet is a clear text, while SSH is encrypted format. Now remember that the TCP port for SSH is port 22. So let me just put the pen here. Pen 22 by default. And the Telnet uses port 23 by default. So for example, if you open, I don't know, TeraTerm or something, if right away, now let's open it. Do I have a TeraTerm here? If I have a TeraTerm, we'll see it very soon. So yeah, TeraTerm. See, I got SSH. Default, the port number, it puts 22 there. If I change it to Telnet, the port number, default port number changes to 23. So remember those two port numbers. So to configure SSH, the first thing that we need to do to configure SSH, let me get that pen. First, we need to have a domain name. So IP, domain name, and it's up to you which one do you want to choose. You can choose anything that you want, cisco.local, I don't know, whatever you wish. Now, it's important to know that if you just pick a name, because the certificate that you're going to create is going to come out from this name. So if you just pick the name, this PC will give you a warning later on. But say, okay, well, that domain doesn't really exist. I can't verify it. So it will give you a warning, and then you have to say, yeah, okay, I know about it. All right. So as long as you remember that, the PC is going to give you the warning. To create the certificate, the switch needs to create that certificate so you can issue the certificate to the PC. To create the certificate, we need that domain name, plus we need a host name. So host name, like just switch, it will not work. It will get an error. So once you give it a host name, you give it a domain name, then you can generate the keys. So crypto key generate RSA. This is a global configuration mode. Now, in the crypto key, it will not work if your iOS does not support cryptographic. Now then the switch is going to ask you, okay, well, how many bits you want to use? 512 is the default. You can change it. You can say, okay, 1024 I want to use. To use this, you need to create a local database. So our database could be local, or it could be in the TACACS or Radius server, anything like that. But on this instance, we are using a local database. Again, remember this is created in global configuration mode, and the command starts with username, and then you give a name their user and the password CCNA. So then once you go in the VTY lines, you say login, not just login anymore, because if you just say login, then you're using the password is there on the VTY line. We're saying login local. So if you say login local, what you're doing, you are using this as your username and password. And then we are saying transport input SSH. By default is transport input all. So anything that comes in, it's fine. But now we want to specify only we want to allow SSH traffic to come in. So once we do that, then this PC will only be able to SSH to the switch. I will put the link in one of the labs is to configure SSH, and you'll see it very nicely. I'll show you the Wireshark. The Telnet is going to be clear text. You're going to see everything, while the SSH you're going to see only encrypted messages. To verify SSH is working, you say show IP SSH, and default is going to be version 2.0. And you can say show SSH. Just show SSH is going to show you the commands that actually what is the user that is actually connected to. the switch or the router. MAC address flooding. An attacker could exploit switch behavior to gain access to traffic normally controlled by the switch by using the PC to run a MAC flooding tool. Such a tool is a program created to generate and send out frames with bogus source MAC address to the switch port. As those frames reach the switch, it adds the bogus MAC address into the CAM table, taking note of the port and the frame that arrived. Eventually, the CAM table fills out with the bogus MAC addresses. The CAM table now has no room for legit devices present in the network and therefore never finds their MAC addresses in the CAM table. All frames are now forwarded to all ports, allowing the attacker to access traffic to other hosts. Okay, what this says is the attacker is going to just keep sending this. It's going to flood different MAC addresses coming in one port of the switch. It's just going to send them on so many frames that the switch is going to just keep trying to keep up with those frames, and it's going to run out of resources for the MAC address table. At that point, when it does run out of resources, the switch is going to start behaving like a hub. So it's just going to flood any packet that comes in. It's just going to flood it out of every port, apart from the port they came in on. DHCP spoofing now. DHCP is a network protocol used to automatically assign IP information. Remember, DORA process. The client sends a discovery message, then the server offers an IP address. The client requests that message. The request says, yes, I do want that an IP address, and then A for acknowledgement, the server acknowledges. There's two types of DHCP attacks that we have. One of them is spoofing, and one of them is starvation. In the spoofing attack, a fake DHCP server is placed in the network to issue a DHCP address to clients. Because the clients, they don't really know who's a DHCP server. All they do is send the broadcast, and they wait for an IP address offered by a DHCP server. Is it a legit, or is it attacker or intruder given an IP address? They don't know. DHCP starvation is often used before the DHCP spoofing attack to deny services to the legitimate DHCP server. So what the starvation is, you keep asking for IP addresses. One PC just asks and keep asking and asking until the DHCP runs out of IP addresses to give out anymore. Leveraging Cisco Discovery Protocol. Now, Cisco Discovery Protocol is very useful, but it's quite chatty, and it reveals quite a lot of information. So for example, if you see two switches or routers talking to each other, with the Cisco Discovery Protocol, you can see quite a lot of information. So for example, let me just go very quickly. I have my packet tracer open. This packet tracer that we worked early. Let me just bring a switch here as well. So put another switch on this here, and then I just do a small configuration on this switch. Actually, I'm not going to do any configuration. I'm just going to connect this switch to the router. So connect this switch. Oh, I don't have any ports. So let me connect it. Okay, let me connect this switch to this switch here. Right. So I'll fast forward the time so we don't have to wait. So if I go to this switch and say enable show CDP neighbor. Okay. So show CDP neighbor. What we can see here, we can see that the neighbor that we have is called S1, and in our interface it's FA016. Their interface is FA06, right? So the neighbor platform is 2960, and the capability is switch. The hold time is 165. So CDP messages are every 60 seconds. We keep them in the memory for 180 seconds, 3 times the hello message. So as it goes down, it should never go less than 120. So as soon as we reach close to 120, we should see a new message. Now, show CDP neighbor, this is like a briefly describing us what is a neighbor. Here we get in there, there, 121, then we got a new message, 179. But if you want to see more detailed information, including layers 3 information, show CDP neighbor detail. So here we have a device ID, given an IP address of the device, the capabilities, as well as the operating system that it's running. Now that's a lot of information. So Cisco kind of tells you that it is a security risk. You really want to stop CDPs pretty much in every port. The only where you can't stop them, the ports that you can't really stop them, it's on the if you connect an IP phone you can't stop there, because IP phone, all configuration comes from the CDP protocol. Telnet, you can use Telnet. Like the Telnet protocol is insecure and should be replaced by SSH. An attacker can use Telnet as a part of other attacks, brute force attack, Telnet DOS attack. When passwords cannot be captured, attackers will try as many combinations as characters as possible. The attempt to guess the password is known as brute force attack. Telnet can be used to test and guess password against the system. Right. Telnet, if we don't stop, for example, the password, so now somebody will just keep sending Telnet and just try different passwords, right? Until they get in. Now, if I'm in this, yeah, I'm in this PC here. Oh, I lost the connection there. Let me just go to the switch then. Switch 0 here. Now, if I for example say Telnet, say I'm Telnet into my router, Telnet.1.1.254. It's not set up, so it's not going to work. Yeah, it's not going to work. Let me go to the router and Telnet to the switch, because the Telnet here is set up. So let me just go to this router, enable Telnet 10.1.1.1. Is it going to work? It should work. Okay, let's show run. I thought I did set up 10.1.1.1. Oh, the IP address is wrong. Okay, so we need to actually change that. So config t interface VLAN 99 shut down and ping 10.1.1.254. Okay, anyway, if I want to explain to you that when I do Telnet like this, by default it will be port 23 hidden there. It would be there, but you won't see it. Now, the user, attacker, intruder could be using this protocol to actually test what port we have enabled. So they can say, okay, Telnet to port 80. And if there's some information come back, they know the port 80 is available. Telnet 443. So that what they do is they're going through the port sweep. They scan in what ports are enabled. Telnet port 25 and so on. So 25. Anyway, the packet tracer doesn't even allow this to add your own port numbers. Very risky protocol anyway. Then best practices, develop a written security policy for your organization. So you should always have a security policy, what you're allowed and what you're not allowed to do on the network of your organization. Shut down unused services and ports. So you have to make sure that all the ports, there's nothing connected on them, shut them down and then stick them onto the some unused VLAN, right? So create one VLAN, call it unused, and then put all the ports on that VLAN. You should really not have any ports on the VLAN 1, right? So if I go to, for example, show VLAN brief, by default I have all the ports on VLAN 1. So what you don't want is you don't want to leave any of these ports. So you want to create one VLAN say 55, a name unused, and then what you want to do, you want to go to all the ports on, for example, say port 18 to 24 are not used. So interface range, so let's do it in range, FA018 to 24, and then shut them down first. So shut down all these ports and then add them to that unused VLAN. Switch port, access VLAN 55, right? Okay, switch port, access VLAN 55, and show VLAN brief. Now you can see that in unused VLAN we put all those 5 ports, plus we have shut them down. So if we say show IP interface brief, you can see that all of them, they should be administratively down, which they are. Cool. That was a second thing, shut down the ports. Third is use a strong password and change them often. Now, you do need to change them every 30 days, and strong password, we mean uppercase character, lowercase characters, you know that, numbers and so on. 8 minimum, yeah? Control physical access to the device, so you need to make sure that they are in lockable cabinets, your routers and switches, hidden from people, you know, hidden from users. Of course, every time you can use a strong encrypted protocol, use that instead of unencrypted protocol. So HTTPS, it is encrypted protocol, use that instead of HTTP. Perform a backup operation on a regular basis and test that backup that it does work. Educate employees about social engineering. Now, this is the biggest problem, you know, because the weakest point of our network is users, you know, the ones who don't really understand the network, you know, security or anything. Because these guys, you can social engineer them. Yeah, you go out, you buy them a drink, a beer, or talk about movies or whatever they like, and they, in the end, like after a few hours of being nice to them, they're gonna reveal some very secure information like passwords and something. So that's, you wanted to educate. You want to, I don't know, hold a training or something and say, don't tell your passwords. Okay. Encrypt and password protect sensitive data. Implement firewalls. And the last best practice, one of the best practices, is keep software up to date. I showed you this, how to disable unused ports, yet efficient security guidelines. All the ports that they are not used, shut them down. You can do it as a range. You can start, all of them you can start shut down and then do no shutdown as you need them. But one way or another, you have to make sure that they are shut down and on the unused VLAN. Snooping, like we said, snooping, this is, okay, well, before I go to this, let me just explain this here. Let me open Paint. Right, so I want you to imagine, okay, here I have, this is my switch, yeah? So this is my SW. Now, in here I have, say, 3 PCs like this. 1 PC, 2, 3 PCs. And this is my server, yeah? So in this server, it's my, actually, this is the DHCP server. So, DHCP. Now, let me connect these together. So switch, connect this, connect this, connect this, and this. Now, what happens, for example, if this PC needs an IP address, what it's going to do? It's going to send a discovery message, yeah? Discovery message, and that discovery message is a broadcast. That to 255.255.255.255. It's going to broadcast it to everybody. So everybody's going to get that message, yeah? So it sends it here, the DHCP will get it, this client will get it, this client will get it. Now, really, what you really want is your DHCP server saying, okay, well, I've got an IP address 10.1.1.5 and offer that, right? Saying, okay, would you like this IP address? And you say, yes, I like that IP address, and then acknowledge. That's a good process. But because it's a broadcast and everybody's getting it, what does it stop that this PC maybe is an intruder, attacker that says, okay, well, your address is 10.1.1.100. Would you like this address? /24, and your gateway IP address, it's me. Yeah. Can you please just send all the information to me? And then say, okay, well, this gets offered. Maybe because this is closer to this PC is going to get it first and say, okay, well, yeah, it sounds good. And every time now he wants to go to the internet or anything, first a packets are going to go to this intruder's going to read the packets and then send them on, forward them, right? So what do we want with DHCP snooping is we want to stop that. But by default, all the ports, when we enable the DHCP snooping, they are untrusted, and this is untrusted as well. So all the ports are untrusted, which means that none of the ports, they can offer you anything. So when you get a discovery message, none of the ports can offer. So you go to the port that it's actually the DHCP server, is genuine DHCP server there, and you make that port trusted. So now, when this guy sends a broadcast saying, I'd like an IP address, please, can anybody get me, sends a DHCP message. Once this attacker sends, oh yeah, again, send it to me. Now the switch says, okay, well, you're coming on an untrusted port, so I'm not going to allow that, right? So the switch protects that. Only this DHCP, only this port can offer you an IP address, which is trusted port. Plus, the switch can limit how many IP addresses you are requesting. So here we go. For example, DHCP snooping allows to configure ports as trusted and untrusted. Trusted port can send a DHCP request and acknowledgement. Untrusted ports can forward only DHCP request. Right. So untrusted port can say, okay, well, can I have an IP address? Well, trusted port, they can say reply, they can offer you something. So first thing you need to do, you need to, let me mark it here. Yeah, you need to enable the DHCP. So IP, DHCP, snooping, that enables it. And then you can enable it on what VLAN you want to enable. 10, 20, whatever VLANs you want to enable. The port that's connected to the DHCP server, which is FA01 here, you want to make sure that that port is trusted, right? And then other ports, FA02, FA03, you can do it with a range here. This one, you want to rate limit them, yeah? So they can ask for 5 DHCP addresses only. Now, if, for example, this switch is connected to another switch, so DHCP is not directly connected, this port you have to make it trusted as well, right? So offers, they come from the DHCP server, and their trusted port, yeah, goes through. Carry on to the next switch, trusted port, yeah, goes through. And then that's an offer. If an offer comes in from untrusted port, it's stopped there. Right, so that's your DHCP snooping. Port security, it will limit the numbers of valid MAC addresses allowed on the port. The MAC addresses of legitimate devices are allowed to access, while other MAC addresses are denied. Any additional attempts connecting by unknown MAC address generates a security violation. Secure MAC address can be configured in a number of ways: static secure MAC address, dynamic secure MAC address, and sticky secure MAC address. So what we're doing here, let me just go back and say, okay, we can keep it. I don't have to clear it. Okay, so imagine that this is the MAC address is AA, yeah, and this PC, the MAC address is BB, and this is CC, and so on. Right, so this port here, this is untrusted port. Imagine it's FA05, for example. Now we can say that in the switch, we can say FA05, right? FA05 has MAC address AA. Now, what we are doing, we are saying to the switch, we are implementing a port security. Now that says FA05, it's AA only. Now if another MAC address comes in on that port, there has been a violation. So then we can do something about it. But FA05, it's AA. That information we can tell to the switch statically. So we can go and configure, say, okay, first find out all the MAC addresses on your organization, which could be like thousands. Then configure it on the switch. Each port, find out where port they connected as well. Or what you can do is you can say sticky, right? So the first MAC address that comes, you say it's valid. Right? The first MAC address comes in, that's fine. That saves you like thousands of PCs or devices that you have to go and look what is the MAC address and what port they're connecting. First MAC address is fine. Now, another way to do it is through dynamically, but again, this is out of our CCNA scope, so we're not going to learn about dynamically. Right, so when we enable port security, by default it is not enabled, so it's disabled, and the maximum number of MAC addresses is 1. The violation is, if there is a violation, it's shut down. Violation is when you have a different MAC address on the port that you assigned a different MAC address. Sticky address learning is disabled, so you have to enable it. The configuration, the first configuration is you need to type this, switch port security. This is the first command. This will enable port security. It's like what we did earlier with snooping, yeah? We said, okay, well, this is how you enable it. So don't go and write the other commands if you didn't enable it. Same goes for the with the port security. The first command is switch port security. Then you tell how many MAC addresses we allow, maximum, and then give it a value. By default is 1. So you don't have to, if there's only 1, you don't have to do the command. And then you have to tell how you learn the MAC addresses, either static configuration, so switch port security MAC address. Either learning them statically, switch port security MAC address, and then the MAC address, or you can say sticky. And then say what the violation, what's going to happen if if you get a different MAC address coming on the port. The default is shut down, so the port will go in the shutdown state, error disabled. Or you can have other two methods, restrict and protect. Protect, what it's going to do is going to actually drop packets from violated MAC address, but not shut down. It's still other is fine, and it's not going to send a log message. I'll explain this on the paint very soon. While restrict will do the same thing as protect, but this one will actually send the log message as well. The shutdown will shut down the interface. And the only way to re-enable that interface is you have to do a manual intervention. You have to go to the port and do a shutdown first. So first shut down that port and then no shutdown. Right, so let me go to my paint, trusted point here. And okay, I will give you another example. Yeah, so what we have is a switch here, another switch, and we have, say, 3 PCs down here. 1, 2, 3. Now let me move this bit better. Maybe AEL access layer switch and distribution layer switch. Okay, so we have 3 ports here like this, connected, 3 PCs connected to this switch, and then we have a like this. So what we want is we want to actually enable port security here on that port here. So there, that didn't work. Port security. So can I write here? Here. Now, once we enable port security here, we need to have maximum allowed MAC addresses is 1. So that's not enough. That's not good. So we have to have a max of 3 equals to 3. So imagine this is our AA, this is our BB, and this is our CC. So what we're saying is 3 PCs should be coming this way, and that we enable port security. But our option was shutdown, restrict, or protect. Now, if, for example, say we have another PC come in, new PC, and I don't know, this PC's MAC address is FF, and he's coming here and is bringing like this. Now, if this happens, there's a violation, because we said the maximum should be 3, right? And we have 4. Now, if the violation is to shut down, if the mode is to shut it down, and that wasn't good. If I do shutdown here, that's going to actually disable for these as well. These good guys, they can't send any packets because the port is shut down. I mean, this guy has violated. Now, in this case, restrict or protect is better, because here with the restrict, what you want to do, the switch will actually stop the packets here. No, sorry, the switch will actually stop the packets, but only from FF. Only this guy is not going to be able to send. So only the violating device will not be able to send. But these 3 devices, as is normal, regular, they should be fine. They shouldn't stop them. That is restrict and protect. One of them was sending, remember, one of them was sending log messages, and one of them was not sending. So protect, not log, restrict, log message. So it's always a situation where sometimes you can't shut it down. You do need to have it restricted mode. Show port security interface FA019, for example. We have a MAC address there. Sticky MAC address 1, and then show run. You can see the configuration there that we have with the MAC addresses. Once the violation has been put and the port is actually disabled, and effectively shut down, the switch communicates this event through console messages. Show interface command also reveals a switch port on error disabled mode, and if you want to enable it, you have to go to the port and do shutdown and then no shutdown. Right, so if you do this very quickly, yeah, so if I go to I was running here, let's see what is this. If I have a look at IP address, so config T, get the MAC address, and the MAC address is this, yeah. So I'm going to copy this, and the MAC address of that PC0 is there, that one there, 0060 and so on. So I'm going to enable port security on this interface. Now this interface, if I just hover, it should show me. Okay, let's connect it to FA01. So first thing you have to do to enable port security, you go to that interface, enable class config T FA interface FA01. And first thing to do is actually enable port security. Switch port security. That's it. Okay. Now it says command is being rejected. So pay attention to these. Fast Ethernet port is a dynamic port. So it doesn't know if it's a trunk or an access port. So we need to tell that is there going to be a switch connected to it, or is it going to be a PC connected to it? So we say switch port mode access. telling that it's only a PC going to be connected to it. Then we say switchboard port security again. Command is valid. When we say switchboard port security question mark, you see they have three options here in the packet tracer that we need to configure. First is violation, right? So let's just do it that way. Violation, and then question mark. See, we have three violation. If I do a shutdown, that's the default. So when we do show running config, it's not going to show. Port security maximum. Now default is 1, yeah, so we can put maximum. If I put 2, it will show in the running config, but if I put 1, it's not going to show. And then the MAC address. So switchboard, port security, MAC address, and in here I can put this address. That's going to be a pain if I have to go to every PC and find the MAC address and the port they're connecting to. Or I can just say sticky. The first MAC address that comes in, that's fine. So sticky. Cool. So when I do show run, okay, let me do show run again. And we can see the port security is enabled, switchboard port security, and the MAC address is sticky, but the maximum 1 in violation shutdown is not showing because it's the default. So show port security, interface FA01. Now we can see the port security is enabled, and at the moment is up. And if it does a problem, we're going to shut it down. And the MAC address, we haven't learned any MAC addresses yet, so cool. So what we're going to do, we have to go to this PC and generate some traffic. So let's ping the router, yeah? Okay, so let's see once we get, if we get a reply to the router. Maybe not. Maybe I put in different VLAN. I can't remember. But anyway, if I go to the switch now, you see that he has learned the MAC address of the PC. So 0060, the MAC address here that you can see. And we have learned one MAC address. There hasn't been any violation or anything. Cool. So now if I bring another, say I bring a laptop here, yeah? And this laptop, I'm going to do the same configuration as the PC. So if I do close this and 10.11.100, yeah? So I'm going to copy that, go to the laptop and configure that. Right, and the mask 255.255.255.0, same, yeah. And what was it? 10.1.1.254. 10.1.1.254 is a gateway. Right, so I'll take the cable off from the PC and I'll put it on the laptop. The way I took it off, yeah, I just click on the green icon, that will take it off. Right? Now, the port is going to go, let me fast forward the time here. The port is green because the reason it's green is because there's nothing, there's no traffic, right? It's still staying in is this one here. So as I go to the root, to the laptop and say I'm going to generate some traffic, so ping 10.1.1.254, going to generate traffic. As soon as I did that, it went red, because there's been a violation now. So if I go and repeat the command, now if you have a physical switch, it will tell you that violation has happened. Show port security interface FA01. Now it says the port security is enabled, but it's down, shut down, secure, and it's shut down, right? Because of violation. And you can see the violation has happened, and the MAC address of the violating device. So that must be the MAC address of the laptop. Now, to bring it back up, you can't just unplug the cable here and say, okay, well, hopefully it's going to work. So if I unplug it and I plug it to the correct PC, doesn't work. So you have to go to the interface FA01, and do shutdown first. Wait till the interface is down, and then no shutdown, right? And then after fast forwarding time, you should be able to ping. Or let's just, I don't know why I can't ping it. That's a troubleshooting issue. So maybe show VLAN brief. Did I change them? 01. I don't know where this is connected. It's connected to VLAN 2. Port 2. Okay, here we go. Maybe I put them in different VLAN. Right, so the PC is able to ping. So if I change the cable again, let's try that again. Go to the, fast forward the time a little bit. Go to the laptop and try and ping that. Oh, it's gone red. Okay, the next thing is, the last thing here is the network time protocol. The network time protocol, we have to have a time synchronized in our network. NTP, it uses a port number 123. NTP can get the correct time from the internal or external time source. Time source can be local, master clock from the internet, or GPS or atomic clock. This is Stratum 0 GPS. We can't talk directly to the GPS. It's the ISPs, they communicate, and they will become Stratum 1. And then once we get the clock from the ISP, then we become Stratum 2. And if we give it to the clock to somebody else, they become Stratum 3, and so on. Now, here's a small mistake here on this lab R1. This should say R1 here. So let me just change it if I can. Right, so I'll put R1 here. This should be R1. R1 is our NTP master. NTP master 1. This is master. So this one here, it represents the stratum number. You can put anything you want here, but in reality, you have to go through like that. If whoever is getting the stratum, then it's going to be one extra stratum from this router 1. And then you have to go to router 2 here and say NTP server 10111. So where to get the clock, or where to synchronize. So this will say, okay, well, this is your server, so synchronize the clock from that machine. To see that we have a synchronization, we have to show NTP associations, so we can see like, okay, we are synchronized with this IP address. Show NTP status. When we see the show NTP status, we should see the first command, clock is synchronized, right? And we are Stratum 2. The reason is we are Stratum 2 because we said that router 1 is Stratum 1, and now we are getting Stratum 2. That's our reference. Okay, if the lab is done, you follow the link to see the lab. And thank you very much for watching this video, and hopefully to see you in the future videos. This has been Astrid Krasniqi helping you going through the lesson of semester 2, chapter 2. Bye bye.